Hello and welcome to C++ Weekly. I'm your host, Jason Turner. I am an independent contractor and trainer. In this episode, I am going to be continuing my demonstration of using the TI MSP 430 with GCC 6.2 so that we have C++ 14, pieces of C++ 17 available, and we've got some blink and light code going on currently. I do encourage you to go back and watch the first two episodes. Now, in this one, I just want to further demonstrate what C++-y kinds of things we can do. The code has a lot of cleanup that it could take, but we are picking up exactly where we left off in the last episode. So let's start with this interrupt service routine. Now, personally, I think it's a little bit of a mess just how this is specified. And, how many different ports are we going to have, whatever. Let's see if we can maybe clean it up just a little bit. And I kind of wanted to do that by giving us some sort of like array of function pointers or something maybe, or lambdas that we can index into. Maybe this is a good idea, maybe not. Not intended to be a best practice or anything, but let's see what happens. So we're going to have an enum of possible interrupt vectors. And I'm not using an enum class in this case because I kind of want it to be something that can be indexed by integer easily. Now we just are going to have port 1 and port 2 in here, and this is going to be very straightforward at the moment. Maybe we'll clean this up in a further episode. But I kind of want to demonstrate some stuff about C++ that you may or not know and how it can be used with virtually no overhead on this tiny device. So we have our two interrupt vectors that are defined using a standard array from C++ 11. And we can include that here. And what I want to do is say if so I'm going to call the function pointer if it exists. And I am doing a default initialization of these, so they will be initialized to 0 or null pointer since they are function pointers. And then I can do a quick setup here. And using the ability of C++ lambdas to be converted into function pointers, non-capturing lambdas specifically, I can say, do this. So now I have the ability to actually swap out my interrupt vectors however I want to because it's simply an array of function pointers. Now let's run this and see if it executes. And it did compile. And now notice we have an array that we created, and we're going to launch into the debugger, and you can see our flash usage has definitely gone up. Now this is where I think it gets interesting, so I'm going to put a breakpoint here, and then this will wrap up this series of videos that I'm doing on this until we decide to add more hardware to do this and start cleaning things up even more and more from our world of C programming. So I'm going to hit resume. Blink and light should be working. They are. We press our button. That kicks us into our interrupt vector. Now notice this. It does a check, which it seems to have actually, yes, it is moving our 12 from the vector, the value in the vector array of the 0th position into register 12, and then it is testing against register 12 to make sure that it is not empty. It is not empty, so then it is simply calling register 12. Register 12 contains our function pointer. So if we step in, actually it looks like I'll have to put another breakpoint in on the lambda because of our optimizations and inlining things got perhaps a little bit. There we go. Yes, it won't even let me put a breakpoint on this at the moment because of our optimizations that have been enabled. So there you go. This is my third video on the MSP 430 with modern C++ development, and be sure to subscribe, follow me on Twitter, and check out any of the links below.